અમારા વધુ લેક્ચર્સ જોવા માટે www.easylearn.oo વેબસાઇટ પર ન્યૂ સ્ટુડન્ટ તરીકે રજિસ્ટ્રેશન કરો. અમારા વધુ લેક્ચર્સ જોવા માટે www.easylearn.oo વેબસાઇટ પર ન્યૂ સ્ટુડન્ટ તરીકે રજિસ્ટ્રેશન કરો.
Hello everyone, how are you? I hope you all are fine and may be able to enjoy your education of 10th standard. Yes friends, I am talking to all the students of 10th standard across Gujarat who are going to appear in the coming March for your board's examination. Friends, my best wishes with you when you are going to appear in your board's examination. But today's class is the class of science and technology, and it's an important class because it's a new beginning. I am going to start a new chapter in this very episode. I am talking about science and technology. Friends, talking about physics section, talking about the first few chapters. I have completed 3 of them, first, second and third. Today's class is an important class because I am going to begin electricity chapter, chapter number 4, electricity. It's a new beginning for all of us because this chapter hasn't been included in your education, in your curriculum since 8th, 9th, and it has been first time introduced in 10th standard. So it will be a tough one when I start the chapter. Let us not waste any time and let us start the chapter, because there are lots of new things to be taught to you. You are totally new to this subject. I am talking about electricity. The name of the chapter, here it is. Chapter number 4, electricity. Friends, talking about electricity, electricity is something which we are using in day-to-day life. In our routine life, without electricity, we are zero. Starting from the early morning, sunrise, when you get up from your bed, you do need an AC, you do need the fan, you do need the tube lights. All this thanks to electricity. Imagine, even if the power cut takes place for few hours, we are restless, friends. We actually are in trouble when there is no electricity. The work is disturbed, the routine life is disturbed, the timetable is disturbed. So imagine how great impact has the electricity been, how great impact is the impact of electricity on our day-to-day life. Now, not talking about the impact, not talking about its importance or the merits, talking about what actually electricity is. Now, electricity is something which is dependent scientifically on electric charge. Yes friends, here we are not going to have a social discussion, neither we are going to have a political discussion, how to use electricity, how not, how it is beneficial, how it is not beneficial. No friends, we are going to look at this chapter only from the scientific point of view. From physics point of view, electricity is dependent on one topic, electric charge. Actually, in order to teach you the compose and essays and letter writing, you should go through first ABCD. In the same way, in order to teach you electric current and its real source, how it has been studied, the basic concept which should fit in your mind is the concept of electric charge. Now, what is electric charge? When I say electric charge is an intrinsic property. Yes friends, please listen to me. It is the intrinsic property. Intrinsic means which lies inside the object. It is the intrinsic property of electrons and protons like mass. These masses are very difficult to define. So this is the exact definition of electric charge. Actually, whatsoever might take place, but there is not a proper definition of electric charge. The best possible way to define it is that electric charge is the intrinsic property. It is a natural property of the things like electrons and protons like masses, which are very difficult to define. Now, let me show you some practical example of electric charge. If you have a comb in winter season, if you have combed your hair, dry hairs, and all of a sudden small pieces of paper will be attracted towards the comb. You might have seen it. If not, just tear few pieces of paper, keep them on the table, comb your hairs, and the comb should be taken near to the pieces of paper. The pieces of paper will immediately be attracted towards the comb. Why? The comb becomes electrically charged. Yes. Same example, if you take a glass rod, rub it on your hair, and then the pieces of paper again will be attracted towards the glass rod. Why? Is there any sort of magnetism? Is there any magnetic force? No, friends. It's all electrically charged rod. When the rod is electrically charged, it will definitely attract the pieces of paper and also some other substances. This is what electric charge is all about. After all, electric charge is an intrinsic, natural intrinsic property of the masses like electron and proton, which are difficult to be defined. Now, the basic two substances which you have to take care of are electrons and protons. Electrons, they have negative charge. Protons, they have positive charge. The magnitude of positive charge and positive charge of proton and negative charge of electron, both are same. The magnitude of the positive charge of proton and negative charge of electron are same, but opposite in sign. The positive charge of proton is plus positive 1.6 into 10 raised to minus 19 coulomb. Now you will say, sir, what is this coulomb? All of a sudden you have taken one topic out of a blue. Coulomb. Coulomb is the unit of electric charge. Electric charge is measured in units coulomb. The unit coulomb is denoted by capital C. All those things will come across. First, let us define electric charge. Electric charge is the natural intrinsic property. Electric charge is the natural intrinsic property of masses like proton, electron, which are difficult to be defined. Electric charge is a natural intrinsic property of the masses like proton, electron, which are difficult to be defined. Electric charge is measured in units coulomb. Electric charge is measured in units called coulomb, denoted by capital C. We are supposed to study two different things, electron and proton. Unit first, let me clarify, unit of charge, electric charge is denoted by C. We are proceeding further. Before that, let us have a quick recap of this much portion of the first topic of chapter number 4, electricity. The topic is electric charge. Electric charge is a natural intrinsic property of masses like proton and electron, which are difficult to be defined. Electric charge is measured in units called coulomb. The unit of electric charge is denoted by capital C. Since it is coulomb, the symbol capital C is used to denote coulomb. Now, talking about proton and electron, we are supposed to focus ourselves only on these two topics, proton and electrons. Protons are positively charged, electrons are negatively charged. The magnitude of both positive and the other's negative charge are equal, but the sign is different. One is positive, the other is negative. The electric charge of proton is plus 1.6 into 10 raised to minus 19 coulomb. In the same way, exactly opposite in sign, but same in value. The electric charge of electron is minus 1.6 into 10 raised to minus 19 coulomb. Friends, this you have to remember from the viewpoint of MCQs. Now talking about the attraction and repulsion. If two like charges means proton, proton, electron, electron, in such a situation, they come near each other, the repulsive force will exist between them. In case of unlike charges, attractive forces will exist between the unlike charges. So let me write about electron and protons charges. The electron has negative charge and proton has positive charge, the electron has negative charge and proton has positive charge. The positive charge of electron and positive charge of proton and negative charge of electron both are equal but opposite in sign. Electric charge of proton 1.6 into 10 raised to minus 19 coulomb. Electric charge of electron now, in case of like charges, repulsive force takes place between them, exists between them, and in case of unlike charges, attractive forces exist between them. Should be the final sentences. In case of like charges, now what do you mean by like charges? Like charges means electron electron and proton proton. In case of like charges, repulsive forces exists between them in case of unlike charges, attractive forces exist between them. That's it, friends. We have completed this first introduction. The introductory topic is over. Let us have a quick recap of this topic. Electric charge. The electrons have negative charge and the protons have positive charge. The electric charge of proton is plus 1.6 into 10 raised to minus 19 coulomb. Electric charge of electron is minus 1.6 into 10 raised to minus 19 coulomb. You see the difference between their electric charges value lies only in the sign. Rest all things are same. In case of like charges, repulsive force exists between them. In case of unlike charges, attractive forces exist between them. Okay, that's it. Now I'm moving to the next topic. The next topic is electric current. The next topic is electric current. Now we are into the chapter. Now the exact main part of the chapter we have arrived. Electric current, we can call it as electricity. Now first, your main question will be, sir, why not electricity and why electric current? Friends, when anything flows, we call it as current. For example, if the water flows in the river, the flow of water, we call it as water current. Please take it logically. When water is flowing in the river, the flow of water in the river, we call it as water current. Now, why not? The flow of electrons can be called as electric current. Yes, friends. That is the main reason behind calling it electric current more precisely rather than calling it as electricity. Electric current, now you know, is the flow of electrons. Electric current, because the word current in English has a specific meaning. Current means the flow, continuous flow. So, the flow of water is known as water current, the flow of electron is known as electric current. So, that should be my first point. As we know that the flow of water in the river is known as water current. In the same way, the flow of electrons. In the same way, the flow of electrons is known as electric current. The same way the flow of electrons is known as electric current. Now, coming to the main part, since we know that electricity is electric current and electric current is the flow of electrons, it ultimately means electricity is the flow of negative charge. That should be our conclusion. The main conclusion which we have to arrive at is that electric current, electricity is the flow of negative charge, rather only charges. Okay, so that should be the perfect definition. The net quantity of electric charge flowing through the conductor. Now, conductor means wire. The net quantity of electric charge flowing through the conductor, that is wire, the net quantity of electric charge flowing through the conductor per unit time is known as the electric current. Now, why inverted comma? It is the definition which you should learn by heart exactly, word to word, including the full stops. Again, friends, we have started the main part of the chapter. Mind well, the main part of the chapter is electric current. We have discussed the introduction, that is electric charge. Coming to the electric current, why current? Why not electricity? Because as we know that the flow of water in the river is known as water current, in the same way the flow of electrons is known as electric current. So, current has been assigned with electricity. Now, the definition which you have to learn. The net quantity of electric charge flowing through the conductor. The net quantity, because after all it's a flow of electron. Now, electron means negative charge, it's a flow of negative charge. So, the net quantity of electric charge flowing through the conductor per unit time is known as electric current. This is the exact definition which you have to learn. Now, friends, if you focus on the definition, the net quantity of electric charge flowing through the conductor per unit time is known as electric current. This is the definition. If you have to convert this definition into mathematical result, what I am asking, I am not demanding something very big. I am demanding from you that you have to convert these words in terms of mathematical result. Then this would be the result. Electric current, therefore, electric current is equals to charge flowing upon time taken. Electric current is equals to charge flowing upon time taken, isn't it? Yes, friends, this is the exact conversion of the definition into mathematical result. Electric current is equals to charge flowing upon time taken. Now, here we are going to denote electric current by some word, some alphabet, charge by some alphabet, and time by some alphabet, like this. Let I is equals to electric current. Let charge Q be the charge and T be the time taken. I is equals to electric current, Q is equals to charge, T is equals to time taken. So what? Just put the values. Electric current means I, Q means charge, T time taken. So I is equals to Q by T. I is equals to Q upon T. this is the mathematical result which denotes the relation between current, electric current, charge and time. Electric current is equals to charge upon time. Now coming in terms with the units. Now you know that charge is measured in coulomb. Coulomb is the unit for measuring charge Q. Second is the unit for measuring time, T. So since the unit of charge Q is coulomb and the unit of time T is second. Since the unit of charge Q is coulomb and unit of time T is second, the unit of current will be coulomb per second. The unit of current will be coulomb per second. Hence, the unit of electric current is coulomb per second. Okay. Again, from top to bottom, this much portion, we have just converted the definition of electric current in terms of a relation. Electric current is equals to charge flowing upon time taken. Now let I be the alphabet indicating electric current, Q be the alphabet indicating charge, and T be time taken. So I is equals to Q upon T. Now since the unit of charge Q is coulomb and the unit of time T is second, hence the unit of electric current will be coulomb per second. So unit of electric current coulomb per second. But is it convenient to each and every time, for each and every time speaking out coulomb per second, coulomb per second, coulomb per second? No, it is not convenient. For the sake of conveniency, coulomb per second has been called out as ampere in order to give honor to the great scientist Andre Ampere. Okay? But in order to honor great scientist Andre Ampere, in order to honor the great scientist Andre Ampere, the unit of electric current has been considered as ampere. Symbol capital A. Now you see, just now we have discussed that the unit of electric current is coulomb per second, but each time it is not convenient to speak out coulomb per second. Hence, a short form of coulomb per second, that is coulomb per second, is ultimately considered equal to ampere. So thus, ampere A is equals to coulomb per second. Okay. Now then you have to come to terms with 1 ampere. What is 1 ampere? When 1 coulomb charge passes through the unit cross section area in 1 second, we can always define 1 ampere. That is, when 1 coulomb charge passes through the cross section of conductor, conductor means wire, in 1 second, we call the current as 1 ampere. When 1 coulomb charge passes through the wire in 1 second, so 1 coulomb upon 1 second, that is 1 C per S, 1 coulomb per second, which means 1 ampere. Electric current is measured in unit called ampere, and the machine which is used to measure electric current is ammeter, a device, that should be my last sentence, the device used to measure electric current is called ammeter. Okay. These are the final words of this topic, electric current. Then we will be actually into the heart of the chapter. Let us have a quick recap of this much written portion. In order to honor the great scientist Andre Ampere, the unit of electric current has been considered as ampere. Actually, just now I have shown you that the unit of electric current is coulomb per second, but it's not convenient to speak out each and every time coulomb per second. And the other purpose was to honor the great physicist, the great scientist Andre Ampere. Hence, the unit of electric current has been declared as ampere, denoted by capital A. So, ampere is ultimately coulomb per second. Now, what can be the definition of 1 ampere? We know that if 1 coulomb charge passes through the cross section of conductor in 1 second, 1 coulomb charge passes through the cross section of the conductor in 1 second, we call the current as 1 ampere. The device, the instrument which is used to measure electric current is ammeter. The smaller instruments are even galvanometer. Friends, galvanometer, ammeter and all those instruments are the instruments used in laboratory, that is physics lab. You might, if you visit the physics lab of your school or your colleges, your cousin, brother and sisters, colleges, you will definitely find galvanometer and ammeter. Anyway, friends, we are into the next part of this episode. We have completed 50% of this episode. We will shortly be entering the next part of the episode with some new important topics. Don't move anywhere. The chapter is getting interesting. Don't move. I'll be soon back.
અમારા વધુ લેક્ચર્સ જોવા માટે www.easylearn.oo વેબસાઇટ પર ન્યૂ સ્ટુડન્ટ તરીકે રજિસ્ટ્રેશન કરો. અમારા વધુ લેક્ચર્સ જોવા માટે www.easylearn.oo વેબસાઇટ પર ન્યૂ સ્ટુડન્ટ તરીકે રજિસ્ટ્રેશન કરો.